So over here, you have a vector question that wants you to use vectors to prove a geometric result. You've got a diagram and you want to show XY is parallel to BC, given a few things. You've got AD is vector A. You've got DB over here is 3B minus A. And AC and AB are straight lines. You're given the relationship between their lengths. AD is the same length as DY is the same length as YC. So the bottom is evenly split into 3 parts. And that AX to XB is 2 to 1. And you want to now show that it's parallel to BC. Well, I mean, we kind of know it is going to be parallel because you know this is 2 to 1. You know this is 2 to 1 because, I mean, that's 1 to 1 to 1. So there is an actual rule that tells you that, well, if you draw a line segment between two sides of a triangle, you know, having split them equally, so 2 to 1, so X is 2 to 1 between A and B, Y is 2 to 1 between A and C, then yes, they'll be parallel to the third side. But I'm imagining we're not allowed to use that directly here, so let's assume we can't. And let's try and do it with the information we've been given, which is A and 3B minus A, noting, of course, that this is 2 to 1 in that sense. Not necessarily those units, but those are the sort of ratios, and this is 1 to 1 to 1. So AD is A, so I guess we'd really want to find, let's think in terms of relative to A. So if this is A, then Y would be 2, AY would be 2A. Now, AD, we've got AD and DB, right? You've got AD and DB. So AD plus DB would be, well, AB. You can see from the diagram, AD plus DB would be AB. So we recognize that AB diagrammatically is AD plus DB. Now, AD is A, DB is 3B minus A, which of course means it's just 3B. So we now know that AB is 3B, but if AB is 3B and AX is 2/3 of AB, then AX is 2/3 of AB, which of course is just 2B. So that's 2B, that's 3B, that's A, and that's 2A. So we now have AX, we now have AB, so we can now get XY. Because X to Y would be XA plus AY. And XA would be negative AX, so it will be negative 2B. And AY is just 2A, as we discussed. So that is going to, of course, be, we'll just take it out as 2A minus B. So we've now got XY is 2A minus B, and we just now need to get BC. Now we know AC is pretty simple. AC, I'll write it on here on the left. AC is 3A. Okay. AB we've already worked out is 3B. So it should be pretty clear to get that BC is, well, BC is, if we do it even direct, we could do like BA plus AC, but let's do it another way. From B to C is going to be, well, C minus B. So 3A minus 3B, which is 3A minus B. Importantly, this is 3 divided by 2 times 2a minus b, where a minus b times 2 is xy. And therefore, that means BC is parallel to xy as required. So this is just an example of how you might use vectors to prove geometric results. Okay. We've just taken particular particular points that have been of interest to us, adding or subtracting as necessary. In this case, you wanted to show that they're parallel. So as long as we can show a vector is equal to a scalar multiple of another vector, positive or negative, then as long as it's just a scalar multiple of some other vector, then we can say it's parallel. And given we've done that, we've now proven it, and that's how we do the question.